Mindfreak.
No, you're out in space. Okay.
Really?
Hey, we're gonna start talking about circuits, and we're starting with Ohm's law, right?
Yeah.
Okay. Yeah.
Let's do this. Okay. You gotta remember this equation.
V equals I
This is
R.
a very important equation.
What is it?
This whole equation is just Ohm's law.
Oh, it's the thing you were telling me.
Voltage, current, you write resistance, you're closer.
Alright, that's
So
fair.
V voltage, I current, and R resistance. Okay.
Yeah, okay. Voltage, volts, current, amps, resistance, ohms. Ohm.
Oh, those are the units. Okay.
Units, yeah, okay, yeah.
Potential difference.
This is not electric potential, this is potential difference. So, but we explained before, but potential difference is change in electric potential. So, it's like comparing distance and displacement, right?
Mm-hmm.
Yeah. So, like, x is the distance you traveled, but change in x is displacement, which was the distance between 2 points. Okay, so, yeah. The V in...
I don't think that works very well, but whatever.
The V in this is change in V. So you can put change in V if it's easier to understand, but it's always just gonna be V basically. Okay. Okay, so there are two different types of circuits, series and parallel. Right now this is a series one. Good job. Anytime you see this symbol, that's just the
Power source creating the potential difference or the voltage. And then this symbol is a resistor.
Yeah, so each resistor has a different resistance. We can just say the power source is like 10 volts. Each resistor could be 2 ohms or 3 ohms. And then each one is going to have a different current running through them, which you could find out using the equation. But right now we're going to cover the total thing, how to calculate the total we can do resistance
Okay, well
and current.
first we need to establish that the current is equal everywhere in a series circuit.
Yeah, in a series circuit.
So the current of the whole thing is equal to the current at one resistor is equal to the current at the other resistor. But then voltage, on the other hand, the total voltage is equal to the voltage at one resistor plus the voltage at the other resistor. And if there's more resistors, then more voltages are required. Same for this one.
Yeah.
Equals. Right.
Yeah. And then total resistance is also adding them. Okay, so we can manipulate the equation to get V over R. That's a really bad V. V over R is equal to I, which was the current, so the voltage divided by the resistance is the current, and since the current is equal everywhere, the current here and there is gonna be the same, so you don't need to calculate either one.
Yeah. Okay, so to find the total current of the circuit, you need to first find the total voltage and the total resistance. So because this is a series circuit, you can just add up the resistances, which in this case would be 2 plus 3, which is 5 ohms. So our total is equal to 5 ohms. And then we're given the total voltage, which is equal to 10 volts.
In many cases, they do just give the power source.
Yeah. Okay, so then to find the current, I is equal to V over R. I total is equal to 10 volts over 5 ohms, which is equal to 2 amps. And because the current is equal everywhere in the circuit, since it's a series circuit, each of these resistors has a current of 2 amps.
Yeah.
Okay.
And you could use that to find the voltage.
for each of them.
Okay, yeah. So V equals IR. Yeah. So voltage of, let's just say the 2 ohm one would be the current, which is 2 amps times the 2 ohms. I can't reach.
That is awful.
You got it. Yeah, I can't reach.
Okay, so the voltage at the 2 ohm resistor is equal to 4 volts. And so to calculate the voltage at this one, we could either do the same process, 2 times 3 is equal to 6 volts, or we could take the total voltage and subtract the voltage at this one, which again would be equal to 6 volts.
Yeah. So if you multiply these two, you get 6 volts, which works with the properties the 2 voltages should add to the total voltage.
Okay, so this type of circuit is a parallel circuit where you have junctions where the current could either flow here or it could flow here. So the voltage in a parallel circuit is equal everywhere, unlike parallel, which they add everywhere to be the same as the total.
Yeah.
And then the current is the total current is equal to the sums of the currents at each of the resistors, which is again opposite to
Yeah.
series circuits.
So those two compared to a series circuit basically just flip flop.
Yeah. And then resistance, the total resistance.
Resistance EQ.
Yeah. Well,
Total
EQ.
EQ.
That's only for a combination.
Okay.
So the total resistance is equal to the sums of the inverses, and then the inverse of that.
Yeah.
So raised to the power of -1.
Yeah.
Or I guess just 1 over the total resistance is equal to
1 over.
1 over R1 plus 1 over R2.
We would suggest just doing it this way because it's just easier. You won't forget to inverse it.
Yeah. And
Yeah.
it makes the algebra a lot easier
Yeah.
than trying to solve for.
R 1 over R total.
Yeah.
Yeah. Just use this equation. Okay. So in this case, we could solve for voltage. Current first. Current first.
Well, total resistance.
Total resistance. Yeah. Okay.
Okay, so the total resistance in this scenario would be equal to 1 over 2 ohms plus 1 over another 2 ohms to the power of -1. So RT is equal to
1/2 plus 1/2.
1/2 plus 1/2, which is equal to 2 over 2 ohms, or just 1 over 1 ohm to the power of -1. The inverse of 1 is still just 1. So the R total is equal to 1 ohm.
Yeah.
So you can redraw this circuit as a series circuit now if you want to, where you just have a single resistor equivalent to just the 1 ohm.
Yeah, that would make these types of circuits a lot easier to calculate. Once you find the total, you can just redraw it as a series with whatever the total resistance is. Okay, so now that we have the total resistance, we can solve for the total current in the system, which would just be V over R. So in this case, the total current would be the total voltage over
Total
the
resistance.
total resistance, which is 1 ohm. So then current would just be 10 amps for the total. So now if we were to solve for the current of each one, it would just be plugging the 10 volts, because in a parallel the voltage is the same everywhere as the total, so it would just be 10 volts over the 2 ohms of the resistor itself, which would just be 5 amps. Whoops. Which would just be 5 amps. And since they're both 2 ohms, they're both 5 amps, which makes sense because they should add to the total current.
Okay, one, focus!
Off your phone, put it in the pocket! Okay, so the final type of circuit is a combination circuit, which is just obviously a combination of a parallel and series circuit. So in both of them, the rules that we covered before still do apply. The one, not really a difference, but when we are trying to find total resistance, which is now our EQ, we still take the same rules. So for a series circuit, it's just the resistance itself of the resistor, which would be 4 ohms, and then plus 1 over 3 ohms plus 1 over 6 ohms, and the inverse of that for a parallel circuit. So in this case, that would just be 4 ohms plus 1 over 3 plus 1 over 6. 3 over 6, which is 1 half to the negative 1.
So it's just 2.
So it's just 2, yeah. So the total, resistance of this whole circuit would be 6 ohms. So then from there we can solve for the current of this resistor, because as we covered before, the current of a series circuit is equal to the total current of the whole thing. So yeah, I is equal to total, which is 18 volts, divided by the total of resistance, which is 6 ohms. So yeah, 3 amps. So the total current and the current of this resistor is 3 amps. And from there we can also use that to solve for the voltage. Voltage is just equal to IR. So in this case it's just 3 times 4, which would then be 12 volts.
So then the voltage at both of these is going to be the total minus this one, which would be 6 volts. So each of these is 6 volts because they are in parallel.
Yeah, in parallel, they have the same voltages.
Yes. So then to find the currents going through each of these, you can just use Ohm's law
Same
again.
equation, I equals V over R.
So for this one, it would be 6 volts over 3 ohms, or 2 amps.
Yeah, 2 amps there.
And then the other one would be 6 volts over 6 ohms, which would be equal to 1 amp.
Which also makes sense because they need to add to the total current, which
is equal to 3.
3.
1 plus 2 equals
1 plus
3.
2 equals 3. Correct.